Okay, no, show me here. Don't worry. That's fine. It's okay. Go for it. Good enough for this. All this. So, welcome to the second session of the Nfvrg meeting. I'm afraid that we have no blue sheets for this session, in despite that we were supposed to have. And well, Ranky is going to. I was looking for them and I could not find anyone. But yeah. Ranky is going to give a second trial. In the meantime, just let me show you the again the same that we should be signing new blue sheets. I had to remind you about the IETF IPR policy. You should be aware of it for whatever you show and say during the coming hour. Well, let's go through in the agenda, what we have is a set of presentations that are not connected to current documents that are under consideration of the research group, but are more photos, intended to be a view of the different activities and recent results that we have, projects, publications, studies that have been recently released by and that we thought that, and that we include your two chairs that we thought it would be of interest for the community. So we will start with an update on OPNFV by Dirk. So now I have to open it, so hold on for a second. So this is 75. Where are you? Nice. So, off we go.
Okay, great, thank you. Almost great, but good enough.
Oh. Oh well. So it was not my fault. That's good.
Okay. Okay, can I get a quick show of hands? Who has been at the lunch talk today by Chris DeBona on open source? Okay, quite a few. So basically, Chris talked a bit about his views on open source project and some pitfalls and his experience. So open platform for NFV, OPNFV is one of these larger open source projects that have recently been kicked off. And so I'm telling you a little bit what we are doing there, maybe giving you some ideas how you could get engaged. So the goal of my talk is actually to make you aware and motivate you to try to think so how you can maybe bring some of the work that you are doing here to this project, because I think it fits pretty well in some of the cases. Okay, next slide, please. So the OPNFV is a carrier-grade integrated open source reference platform for NFV. So what does it mean? So I mean, of course, I don't have to explain NFV to you, but in general, the idea is that so at the end of phase one of the ETSI NFV ISG, it was pretty clear that so NFV as a concept and like technology platform is here to stay. And then the question is, okay, how can we expedite deployment, take up? How can we support future standards activities? And so the conclusion was to start a open source project that would develop this reference platform. So to validate standards, to validate standards, to provide feedback to different groups, so say regarding implementability, but also to really provide a usable, so carrier-grade platform that can really be used in deployments, and where other companies in that space can build innovative solution on top or on the side. Next slide, please. Okay, so it's a little bit, okay.
No.
Right, so I mentioned this. So we are doing this by bringing together say a large set of vendors in this space, but also users, so operators, service providers, and so on. So they are part of the project, and they're also contributing requirements and give us feedback. And as you know, I mean, in the NFV space, we are working with many existing software projects, so like the Linux distros, hypervisors, software switches, software management systems like OpenStack and so on. And so OPNFV is taking them, integrating them, improving on them, or suggesting further enhancements, or working with those communities, and kind of looking at particular, say, interesting, from a carrier perspective, interesting optimization opportunities. And so the idea is to establish this NFV ecosystem by providing a common like baseline where you can kind of build your differentiating features on top. And of course, yeah, we're trying to promote OPNFV as the preferred open reference platform in the space. And next slide, please. So the scope is fairly well defined. So OPNFV is basically really focusing on the virtual infrastructure and its management. So things like platforms, so for networking, compute storage, and their management, so OpenStack, for example. But there are, of course, other components that, so like in terms of software projects that play a role, like, for example, SDN controllers, and so on. And on the next slide, you kind of see the architecture framework diagram with the OPNFV scope. So the focus is on this lower part. Of course, that means in order to build systems, you also need to look at the interfaces, for example, to VNF management, and kind of provide examples how the system would be used in real-world applications. Okay, that's what we are doing right now. Next slide. And so I will mention that we are, say, working intensively with these upstream projects. So we're integrating the work. So we are, for example, proposing blueprints in OpenStack, and so working with the community. So all in all, it's often also the same group of people, right, who are working in OPNFV, or same group of companies, you could say, and OpenStack. So it works pretty well to move the requirements from like one community to the other. Okay, and next up. So the kind of workflow, and if you are familiar with other open source projects, so bigger ones like Open Daylight, for example, you will find this familiar. So there is a proposal phase if you start like a new sub-activity within OPNFV. We have some incubation phase where we kind of develop the thing further. And at some point we kind of try to make a decision, okay, this is mature enough that we can integrate it into, for example, the next release. And so in OPNFV, it's kind of structured in different categories. So documentation, requirements, integration and testing, and collaborative development. So in the first phase, of course, we're mainly trying to get something out. It's not so much about like developing new features. And on the next slide, I can just go ahead. So requirements projects, they are basically looking at gaps, right? So what topics like fault management, for example, and try to suggest activities in OpenStack, for example. Next one, just click ahead, please. Yeah, so these development projects, that's real software development on particular topics. So it's, for example, new approaches to service training or something that would be a topic that OPNFV would do by itself. Click ahead. Integration and verification, this is basically the groundwork that is required for a big open source project, so to kind of automate the verification processes. And next slide. And of course, there's also lots of documentation required. Yeah, go on. Right. So again, I can't do anything about this. So then, okay. So so the main activity at the moment is basically to kind of bootstrap the project. So it started in the end of last year, and bootstrapping here means we are basically selecting components and trying to fit them together, trying to automate their deployment and so on. So so you see a range of components we're using for that. But at the same time, basically, so work also has started on these other type of projects, so the development and requirement projects. So there is a set of projects on automation, fault management, so other carrier grade features, so like performance optimizations and so on. And so and this is here on the right hand side. So if you download the slides, you see a couple of projects concerned with like integration, testing, automation, and so on. Right. Right. So this is the complete list of projects for your reference. You can see there's already a lot going on, and so one of the reasons why these are so many is actually this is not a say monolithic activity that tries to rule out competition and kind of slow down innovation or something, as sometimes people think when they see a big open source project. So some of those activities are actually competing with each other. So there are different approaches to service training, for example, different approaches to software-defined networking. So for example, I give you just example. There's actually 3 approaches to SDN control. So an open daylight project, a contrail project, and maybe a owners activity in the future. And so the way how it works is that we let them go and kind of see what comes out, and then at some point do a decision. So what of those is actually mature enough and useful enough to be adopted for a release? All right. So I just give you 2 examples of like different kinds of projects so you get an idea. So what OPNFV might be doing. So that we have one project on fault management that is called Doctor, and that's basically trying to improve the way how the infrastructure management and its users basically can detect and work with failures in the virtual infrastructure. So how to get the information, how to escalate it if needed, or how to like self-organize manage failures. And so this, for example, is resulting in a set of blueprint proposals to OpenStack. Right. And so another one is, so we call that OpenStack-based VNF forwarding graph project. So that's taking the current work that is done in ONF and Open Daylight, so like the open flow-based service training approach, and the current intent-based northbound interface activities in ONF, and build a service training solution that is integrated with OpenFlow for OpenFE. So this is, you could say, a bit more forward-looking, so it's like an ambitious activity So something that probably could fit quite well to some of the activities that we talk about in Nfvrg. All right. Yeah, so there's going to be a first release coming up pretty soon, so end of April. And sorry. So this is basically, as I said, so mainly concerned with picking the initial set of components. Open Daylight, specific version of OpenStack, self-open vSwitch, and CentOS, and then adds some support for automated deployment and testing on top. So we are working largely on a 6-month cadence for releases, and so the expectation is that so after this first release, then the upcoming ones would contain more functionality and so more output from these projects. And with that, thank you very much. Please check it out and contact me if you want to learn how to contribute.
We had time, thank you, Dirk. We had time for a couple of, 1 or 2 questions, and in the meantime, I will try to fix, because I think it's part of the configuration of the.
Robert Sabo, just one question. Do you foresee any integration between these projects? You mentioned that there are several projects starting, but at a later time, do you see any plans to integrate these?
You're asking for integration of these different internal OPNFV projects?
Yes, different components or solutions into a...
Yeah, sure. I mean, sometimes they're also complementary, so it's not all competing projects. Yeah, for sure.
No, sorry. It was saying no to me, no,
okay.
It was not matter of the configuration. Sorry.
Carlos Bernardo, Dream. I don't know if I got it right, so maybe I missed something. So the idea is more to focus on integration, or also to focus on develop new code?
Both things. Both things.
On the table, most of it was on integration efforts, right? But both of things are on the scope.
Yeah, sure. I mean, it's currently to get something released soon. It's more like picking the components, making them fit together, and automating their deployment. But as you have seen, there are many technical topics that we are looking into, and this also involves software development.
No, stop. Okay.
Thank you.
Thank you, Dirk. Our next presentation is about the Cable Labs project on virtual home networking. So, Don, who I work you, for those of you not knowing him, he's one of the original ancestors of NFV. So you have to treat him with a high respect.
I doubt it very much, actually. So, yeah, Don Clark, Cable Labs. I've managed many teams, actually, in my R&D career that have been heavily involved in the IETF, but I've not personally attended the IETF at all in my many years in the industry. And I was forewarned that you guys could be pretty rough, right, on people. So I was very careful not to include any technical content in my slides in order to be immune from harassment. So next slide, please. So, no, seriously. Actually, this is not my latest presentation. Can you put the? Oh, doesn't matter. It's probably the same content. It has got some content in it, guys. Come on.
It's not just one.
So anyway, at Cable Labs, Cable Labs is an interesting entity. I joined Cable Labs about a year ago. It is wholly funded by the cable operators. So we've got global membership cable operators, 56 cable operators spanning the United States, Europe, and Asia. And we've got a program called Cable Cloud, which is looking to see how cable operators can virtualize their network infrastructures and leverage the benefits of open networking and NFV.
Let's see if the presentation I have in my laptop works.
That's what it should do. Oh.
No.
There we go. Great, thanks.
Is this?
That's cool. Okay, great, thanks. Virtual home networking is the first project that I was given to manage. The good news is I don't manage it anymore. My colleague Michael Clobberton, if Michael's around, manages it, and Michael, if he's not around, is actually getting our demo ready for virtual, the bits and bytes thing this evening. Got a blue tinge.
Yes.
Okay, great. Next slide, please. So, many of you will recognize the challenges for home networks, right? So increasing complexity of end-user devices, multiple routers appearing in the home to do all kinds of things, and this is causing problems for service providers, right? They've not got complete visibility to the end-user device, but those end-user devices are consuming the service provider's services. So when those services go wrong, the service provider has got very limited visibility to actually do troubleshooting across that home network. So the idea here is to try and use virtualization techniques to give the service provider better ability to manage that home network, troubleshoot, and indeed to offer new services. So next slide. Interesting idea within Cable Labs is we're using, and I saw a presentation earlier today on DevOps. DevOps and lean startup methodologies are very interesting techniques that we've stolen from the software industry to increase and accelerate our R&D. So we instead of spending many months of detailed analysis coming up with some big report at the end of it, we're actually taking the problem and we're dividing it into individual challenges, and we're analyzing those and then basically feeding results into our service provider customers, giving the rationale and asking them whether they agree that the result that we've come up with is an approach they want to move forward with. So this gets learning very quickly across a very broad spectrum of people that we want to influence with our work. We're focused on open source solutions and standards. How many of you were in Chris de Bono's lunchtime talk today on open source? I was a little bit disappointed with that session because it really emphasized more to do with licensing than the real advantages for me in open source. For me, open source offers a huge number of benefits, such as deduplication of core development. We can all use the same bits of code that are the basis for all our products, but we can then innovate on top of those. What I got from the lunchtime session was that open source is about innovation. Actually, open source facilitates innovation. The innovation is often in the vendor community that will then add their value on top of the open source. So that is the message I wanted to get across this afternoon, that we see open source is a way for the vendor community to focus on the innovations that differentiate their products, rather than having to duplicate each of the core components that are necessary for the end product to work in our network. And there's a list of open source communities that Cable Labs is involved with, notably Open Daylight, OpenStack, and of course thanks to Dirk for your presentation of OPNFV, one of my favorite projects. Next slide. This is the architectural vision that we're talking about. Virtual home networks in the Cable Labs or cable industry context is not about virtualizing the CPE, right? So we're not thinking about, how can we get rid of that piece of hardware from the home. We're looking at virtualizing the functions that are necessary for delivering connectivity, and then seeing how that impacts both the devices, notably the cable gateway, the cable modem transport system, and the MSO, the multiple systems operator, cable provider, internet service provider, virtualization platform. So there's a kind of bunch of fairly randomly named virtual functions in the cloud, and a couple of fairly randomly named virtual functions on the gateway. What we're basically saying with this project is we want to give our cable operator service providers, and indeed in an industry standards context, anybody that wants to engineer an end-to-end network, the option to instantiate functions either in the cloud environment or in some intermediate place. And that intermediate place could be wherever there's a physical node. So if you're a mobile operator, that might be at the radio base station. If you're a cable operator, it might be at the fiber node. But also, from the point of view of home networking, what might be instantiated on the cable gateway itself, and what kind of resources would be necessary within the cable gateway to do that. And then if we virtualize things on the cable gateway, what happens when the access goes down? So, for example, we've got the routing functions virtualized in the MSO environment, and the WAN goes down. Does that mean we lose routing within the home environment? So I can't see my printer from my PC. Well, those are the kind of things that we've analyzed in the project, and we've come up with approaches that we believe are realizable and can be deployed within a reasonably short period of time. And we're trying to figure out ways in which this enables the cable industry to come up with a set of scenarios which call out standardized functions from the open source community, as well as the traditional quote-unquote standards community, including the IETF. I think my last slide is. So we've got this, I said earlier on, this is really a bit of an invitation, really, to the vendor community to participate in helping us move the project forward. We've got a number of vendors involved already. In order to be involved, there's obviously a non-disclosure agreement. That's really about protecting the discussions and helping them to be fairly open and free. But that's not to say that everything we do is sort of secret. We are going to be pretty open about our results. We're going to be coming into the IETF, into the relevant projects with contributions, and we're going to be contributing code, data models and APIs into the open source community. So I have access to a team of developers that are pretty experienced. They're already pretty active in the open source community, and they are a resource that I'm very pleased to have. We've got a prototype under development. I think Mike was going to demonstrate something in bits and bytes, but I'm not sure about that. So with that, hopefully I've survived my first foray into the IETF arena.
Don't say that too soon. And stand there. The camera is recording you.
Shri Gundavalli, Cisco. So you said one thing. So the virtual home is different from the virtual CPE architectures that are the efforts that are happening in the industry. So I am associated with that project on virtual CPE. From what I understand, at least the work that we are doing at Cisco, virtual CPE is essentially the ability to move certain functions from the CPE and run it in the cloud, right? So you can realize that in multiple ways. You can create a virtual machine instance for every physical CPE, run all the layer traffic through that CPE. That's one model. Or run the traffic from the CPE, classify it, and run it through a service chain on the BNG, right? How is that different from the virtual home that you guys are? How is that different from these efforts that you guys are driving?
It isn't. I mean, I was just trying to emphasize that we're not. This is not about simplifying the CPE. That's the main message from this. It's about managing the home network better by virtualizing the functions. So, of course, you could virtualize pretty much all the CPE functionality and put that in the cloud. I'm just basically emphasizing that's not the focus of the project.
Okay. So one additional comment. You said the increased visibility into the home, or at least that's how I took it, one comment. Second point you said was essentially about diagnostics or something, essentially the ability to diagnose whatever something goes wrong in the home. What is the architectural assumption here to realize that?
The architectural assumptions are that there will be the abilities to diagnose problems within the home environment. As to what they will be is part of the study activity within the project itself. So very important to be able to do that.
Thanks.
Bob Briscoe, do you see this as having any visible benefits for the customer, or is it mainly an internal benefit for the cable company?
You see?
I love it. No, it's a great question. I love the question, Bob. Thank you very much for trying to trap me. It's absolutely about choices for customers and improving the customer experience. The thing is, it's a virtuous circle, isn't it? If you supply customers with services that they enjoy, and when things go wrong, they preferably don't even know they've gone wrong, then you sell more services. So it is very much about improving customer experience.
But how? What specifically is different from what you've just implemented it differently. What's different?
Well, for example, be able to see beyond gateway into home, beyond that gateway into the home, beyond the routers, potentially by loading functionality on the routers, so that we can diagnose problems and see the connectivity beyond that gateway. If we can see the connectivity beyond the gateway, then we can verify that the router is actually connected, and maybe it's a problem with the end user device Wi-Fi configuration, that kind of thing.
But you could do that without virtualization?
Yeah, for sure.
But it just gives you the flexibility to do it earlier. Is that what you mean?
I think it gives you architectural flexibility. You can put the functions either in the MSO cloud or on the gateway, or potentially load them onto the end router device. So it's really about providing choices and architectural flexibility.
Okay, thanks. No, Georgios, if you don't mind, we are running out of time. Unless it's something very, 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 very short, and you don't look like that. So.
It might be short. I'm not sure about.
No. Then let's go on later on, because we are running short of time. Sorry. Well, the next in the line is me, so you can understand that I prefer to have a little bit more of time for me, which is here. So don't you mind to change it, or shall I use this? Okay, so we can use it. This one. Now. So, before I start this, Aaron from the Wisconsin is still here. Could you stand up, please? I committed before the horrible mistake of having Aaron making a question on the mic line. He is the winner of the Applied Networking Research Prize from ISOC this year. So I would like to well, it's very much related to this we are talking here. So I would like to greet Aaron with a great applause from the group, because he's making a really outstanding contribution. Well, now this said, let's go to the unimportant things. This is the first. Well, this is the first public presentation of OpenMano, which is, as I said there, is the data plane, ready, open source NFV Mano stack that we have built in our labs. Well, basically, the reason for building this is that when you move to the data plane and when you try to virtualize functions in the data plane, you realize that it's not simply moving the functionality to the cloud. It's not applying cloud to carriers. It's something that is a little bit different, and essentially because two things: the kind of, well, not necessarily, it's not the size of the workloads. The size of the workloads can be very, very high in other cases. If you're doing Hadoop MapReduce, can be extremely high, but the characteristics of the workload are different, first. And second, you have to follow the shape of the network. This is very important as well, because you cannot forget that you have to attach the functions to endpoints, and you have to provide the functionality according to certain, well, to where the network is, and you have to put the different functions in the appropriate places. So that means that you cannot follow, and this is something that we have been experimenting with, you cannot simply follow the cloud placement, the cloud orchestration procedures, and you need to go a little bit further, not only in the orchestration, but as well in the implementation to deal with the workload. Next one, please. For example, something that we have found is that to have network functions that work in the data plane that not only perform at a high rate, but as well that are able to provide us a predictable performance, you need to apply something that, well, we call it in several ways, but some time ago the people from Intel came with a way of calling it is enhanced platform awareness. Essentially, it's to apply techniques that have been applied before in high-performance computing, like non-uniform memory access, like the possibility of using the memory in unconventional ways, the possibility of trying to avoid or shortcutting the bus communications with different processors, etc. So you move from the view that the cloud has or provides to the virtual machines, that is essentially you have a uniform memory, you have a uniform CPU, you have a uniform way of dealing with the input-output, in a way in which you can make some tweaks to optimize that performance. For example, you are able to use the pages in the memory in a different way, and to locate locate certain set of data close to the cache, so you can improve the performance. You can avoid the memory translations when you are doing input-output. You deal with the drivers in a different way and not necessarily via a construct like a virtual switch. And you, very important, you minimize the inter-processor communication because they are extremely costly in terms of performance. Next one, please. And not only that, you have to avoid as well the bottlenecks in the hypervisor and the OS. Let me say this is for the data plane. This is nothing to do if you're running a DHCP server, if you're running a radio server, if you're running a PCRF, or you're running components of the IMS architecture. This is nothing. Is not required. But if you're running something like a virtual router, and if you want to give us the same performance, it's really important that, for example, you don't require to go through all the stack of the vSwitch and the operating and the host the guest operating system just to do that. So you rely on specific software libraries that are able to provide direct access to the hardware that has to be allocated. So, well, yes, that's Sarah. I know that sounds like you're killing virtualization. No, we're not killing virtualization because it's a software image that you can locate freely on the cloud-like infrastructure. What you're not doing is that you are sharing it using the common platform that it is provided to you by the virtualization platform. You're running on top of a virtualization platform, and you're just shortcutting what affects your performance, and that makes your performance not consistent across different deployments. So this is something that we have been working with the collaboration of people from, it's nothing strange. We have been doing this with the collaboration of people from Red Hat, with Intel. This here is essentially DPDK. Nothing, and is essentially DPDK, and it essentially could be Open Data Plane as well, but we have a collaboration on it. So it is DPDK. Next one, please. So, and this is something that we have recently demonstrated in Barcelona in the Mobile World Congress. Where else? Close to home. We were playing at home, and just to show, there are three virtual routers showing that, well, using a traditional, with the same VNFs, the same servers, the same switches, using different way of deploying the VNFs and different ways of playing with infrastructure. And in one case, we were using OpenStack, playing OpenStack. In the other case, we were using our enhanced platform-aware Vim and our orchestration stack that was platform-aware and knowing about this optimization. Next one, please. These are the results. This is the results with packets of more than 1K. Well, you see that two important things. Well, when we're talking about the green is our setup, is overperforming it. But the important thing is not about performance, frankly. We're not talking about that you can get a throughput of 10 or 100 packets per second or whatever. We're talking about to be consistent. If you look, the line, in the case of the green line, is completely straight. The red line has irregularities. And this is something that is what is really complicated to deal with, precisely with the non-sustainable, non-consistent performance. Next one, please. But the curious thing is when it comes to small packets. The outperformance is 2 orders of magnitude. And small packets are really a real challenge because they imply a lot of movement in memory. And well, for this, it was quite curious because for the show, my colleagues told me that they had to adjust the scale, so the red was at least shown there because the 2 orders of magnitude made it really complicated to show it. Next one, please. So for this, to achieve this, we found that the current orchestration systems were not supporting what we needed. So we started working in something that it was something that we started to do at home for our lab and to demonstrate this. Once we went into more detail and we talked with some of our partners, etc., they told us that it could be reasonable to try to contribute it to the to try to contribute it to the open source, to see whether others could find it usable, and well, if they are willing to contribute us back, even telling us that it's pure crap and they don't want it at all, and this would be a good result. Well, here it is. It has an enhancement for awareness aware Vim that is able to do NUMA pinning or defining the network infrastructure by directly connecting OpenFlow to the OpenFlow external switches. It has a performance-aware orchestrator, and it has a generic BNFM that, I must confess, is under development. So far, we are running without BNFM. The NFVO does whatever is required to the lifecycle management. We're working on that. It is available there in the GitHub repository, and it's called OpenMano. For those of you who know Spanish, there should be many. Mano means hands in Spanish, and by chance, only for you to know, that Hans is one of the main authors of the. Really, I mean, we take a snapshot of his hands. So whoever that wants to evaluate, whoever that wants to contribute is welcome. And now let me confess one thing. The Vim is not based on OpenStack. It's not OpenStack. Oh, great thing. Yes. Why? Because the current version of OpenStack, next slide, please, doesn't support this EPA awareness. And what we wanted to avoid is this. The situation in which you take the OpenStack and you make some modules, you put them as add-ons, and you contribute. You don't contribute them, you leave them over there, and then you are completely locked in to a version of OpenStack because the extensions are for a certain version. What did we do? We have contributed this to the OpenStack upstream. We expect to have those extensions as part of the Kilo release in the future. But right now, OpenMano, if you download OpenMano, don't be afraid, has no OpenStack. And you will be the bold ones that are dealing with with NFV without using OpenStack. And well, this is, this is a real select club. Next one, please. And is the final one. This is the plan we have. We started playing with the idea of having our orchestrator and your manager for this vertical integration for our lab. We found that it was possible to make it a little bit better structure. So we we have this. We realized dealing with OpenStack the first way we thought it was not the right way. So we created our own Vim, and we plan to converge. Though there is some internal discussions that maybe this way may have some sense, even in the future. Even if we converse with OpenStack, may have some sense because it's much more lightweight. It's not a full-fledged OpenStack, it's a very tiny one, and for certain environments, we believe that could make sense. For example, we have been talking with some people that are working on precisely what is called virtual CPE, the virtual CPE for enterprises, and that they are now trying to base there are some ideas about having some kind of a split. So to have some part of the CPE still in the customer premises and to have some part of the CPE on the cloud. And in those cases, maybe there is a tiny orchestration stack could have some merit in the small piece that you leave at the customer premises. This is something that we are thinking about. This is something that if you download it, you play with it, you have an idea of how it goes, it would be great to get some input back from the community to see whether you see any value in the whole thing, in keeping this tiny thing or whatever. I'm done. I hope on time. So if you have any questions or you want to throw something at me because we are...
Diego, Bhumip Khashnovich, I have one short question. Can you go to your first slide?
First one.
Yes,
Name, please.
The very first one? Or
Bhumip Khashnovich.
Name and affiliation, please.
No, he said so. No, he said so. No. The first slide.
Not the title on the first slide. The one, yeah. The last statement in the blog, adapted virtualization environment is needed to obtain carrier class behavior.
Yeah.
Could you please tell us what you mean by carrier class behavior? Thank you.
By carrier class behavior, we mean here precisely something that provides a performance that is acceptable for our operational guys to substitute the physical functions for the virtual functions first. And second, and most importantly, precisely, something that provide a consistent performance. That wherever you make a deployment, you know that you're going to get 10 gigs, 10 megs, 1K, but always the same. Because our experience with the vanilla cloud, it was, well, from sometimes it was 1 gig, something that the cloud management system was telling us it was the same deployment, exactly the same. From time it was 10 gig, 10 megs, 100 megs, 150, and that was something that it was not acceptable because our operational guys would kill us, simply.
Aaron Gumber-Jacobson, University of Wisconsin. I'm really excited to go try this. I've spent a lot of time fighting, trying to get good performance out of OpenStack and Open vSwitch with middle boxes, and it's just not happening. So one quick question I had is that how does, as you start to think about doing something like service function chaining, where after you pass through one NF, you want to go to many different ones, how does the number of different ways you're splitting your traffic ultimately impact the performance of switching?
So far, we are starting to do training. We are very few. We are very much focused on a couple of projects that we have been assigned a very tight schedule to show that this can deliver. So we are very focused on something that is connected to this home virtualization Don was mentioning before. And so the service training is very limited. I would say we're talking about not more than 3-4 functions right now. We have plans, and well, right now the stitching of the functions is done through directly through the open flow controller in the Vim. We have plans to explore the idea of a general function chaining later on. So this is something that, and well, if you want to somehow think about how to merge this with OpenNF, this is something that I would be really interested to hear. So now,
Roland West, KIT. Can you go back to slide 4, please?
Slide
forward
4.
in this case.
No, that's no, the other direction.
4.
For
This one, yes, exactly. If I understood this correctly, you are using DPDK.
Yep.
So
well, DPDK.
Are there any issues? Sorry, my question is: are there any issues with isolation in this case? Then
there were issues with isolation. There were issues, but what I forgot to mention is they are using a modified libvirt as well.
Okay.
So the idea is that you assign, because one of the tricks here is that for each kind of process you have a set of resources assigned. This is, I mean, we are forcing a little bit, pushing down the stack some of the virtualization to achieve this sustainable and predictable performance.
Yeah, okay. So you're basically also limited by the number of cores and hardware. And
when going to deploy a function in the data plane, yes.
Yeah.
Because the fact is that you can choose whether you want to go data plane style or you want to go other plane style.
Yeah. Okay. See.
Thank you. You will allow me? No. You will allow me to cut the line because otherwise, Bhumi will not have nothing. We can.
Yeah, it's fine. We'll discuss after. Yeah. Thank you.
Okay. So Bhumi, let me play the chair. Come here. So. Sorry? So let me look for it.
So as you can see, I'm not Dr. Mo. My name is Bhumi Khasnavish. So I'll be doing the presentation on behalf of him. So if you have any questions or comments or suggestions, I suggest you send those to the distribution list. You can ask me some of the questions. I'll try to answer, but maybe I'll not be able to answer.
You have it.
So that's why I asked this question to Diego, what he means by carrier class. Because every time we talk about NFV and virtualization, the traditional service providers, they ask us this question. Can we expect the same kind of behavior as our customers expect or we expect from the traditional like PSTN or carrier grade equipment? So you can set up a test bed, or you can run simulation, or you can develop analytical model. There are varieties of ways to solve this problem. So the next few minutes, I'll be talking about, I'll be going through some of the selected slides, not all of the slides. If you are interested in the details of the development of the model and analysis, there is a reference to journal papers which we have published in the GT Communications magazine. That's a shortened version of the entire report, which is more than 100 pages, but you'll get the idea of how these things are being developed. So I'll be talking about the reliability of NFV using COTS, common of the shelf hardware. So the outline is, what's the difference between traditional telecom domain hardware and the common of the shelf? And we'll talk about the analysis framework. As I said, it's simulation and also Markov chain model. Like anybody who has done state transition diagram, you will see we'll start with short, and then we'll keep on adding the transition states. The states explode. At some point, you have to limit it because the equation becomes unmanageable. And then we'll talk about the enhancing application reliability via backups. Traditionally, people try to do 1-for-1 backup, 1-for-2 backup. But the point is, if you keep on adding the backup servers, it adds the complexity. But the marginal gain, it's not as high as you expect. So instead of 1-for-1 backup, if you have 1-for-2 backup, or if you have shared operation, so you can see how these things change. That's we also included in the model. And then we'll talk about some of the results. Next slide, please. So the traditional telecom hardware, as you know, they have strong fault detection and fault isolation capability at the hardware level because the hardwares have been hardened to operate in the harsh conditions. And well-established traditional on software upgrade and patching. Anybody who has experience on PSTN switches or network, you know that they have scheduled maintenance window at 3 a.m. in the morning for half an hour or something like that when the traffic is very low. And then reliability of the central office is assumed. That means 5 nines of availability, like call completion time is within certain limit, and also the quality of the data plane, control plane, and also the uptimes, this has to be significantly high. Now in the COTS hardware, so they may have smaller mean time between failure and the mean time to repair. And the COTS procedure for software upgrade and patching and maintenance, those are not well scheduled or well established time window. So the different grade of reliability for different data centers. So we looked at the NC TIA, one of the specifications, they have defined 4 types. So what we did, we took those 4 types of description and then we modeled those. Next slide, please.
You know that you have 7 minutes, right?
Yeah. Okay, so I can go to the main point. So the main points basically is the COTS procedure for software upgrade and patching. Those things are the main culprit, because if those things are unpredictable, you will see that the site downtime for type 1, type 2, type 3, and type 4 data centers, it can vary from 99.671 to 99.995, which is almost 59, which is the traditionally carrier grade. Yeah. So this is the traditional 1-for-1 backup. Next one. And next. So in this one, you can see the system availability is P1 times P2, which is the P1 is this availability of the left side block platform, and the P2 for the right side, and the connectivity also contribute to the reliability and availability. Next one. So is it possible to have servers with 4 nines or even 3 nines of reliability and availability to provide the 5 nines? So the answer is yes, but the marginal gains becomes low as you keep on adding more servers. Next one. So this one is 1-for-1 backup. Next. So this one, as you can see, 1 primary backup, 1 secondary backup. But the point is you have to do the synchronization of the master with the slave server 1, which is backup 1. And in addition, you have to do the synchronization of the slave server backup 2 with the master as well. So it adds additional complexity because you have 2 backups. And the paper I was mentioning is available in this URL. Anybody interested, you can go and download the paper. And as I said, this paper is a shortened version of the big report. Anybody interested, send an email to the distribution list. We can share the detailed report with you. Next. So this is marginally better than the 1 backup. And then this one is running, the third option is running the load sharing mode. So every time the request come, you can round robin between the first server, second server, things like that. Next one. So this is same as one-for-one backup. And the next one. So this one is the load sharing mode. Next. So as you can see, this is same as also one backup. So as I said, the detailed results and analysis, simulation and analytical results you can find in this paper, which is in this URL. Next. Next. So this is the simple markup state, two-state markup model. The server is good and the current master, and the server is bad. So this is typical two-state transition model. So this is the simplest model. And then when you add the complexity, next. So intermediate states, the silent error probability. So in this case, the S1 and S2, one server is good, one server is bad. And then we use this state and the transition probability to develop the mathematical model. Next one. Next.
No.
Okay. So as you can see, as you keep on adding the servers, and if the server mean time between failure and the silent error probability, you increases 1. As you can see the server with 6 nines. So 1, 2, 3, 4, 5, 6. You can achieve those kind of availability. Next one. Yeah. So with the mean time to repair, it's also, as I said before, the improvement is significant, is not as significant. So with 5 backup, you can see mean time to repair 12 minutes and 6 minutes with 10. So the improvement is not as significant. Next one. So these are some of the simulation results, not much difference between what we got from the analysis and also from the simulation. Next. So again, improvement for 1+2 dual backup. This, as you can see, you can achieve improvement, deteriorates fast with the silent error. Not significant, improvement is not as significant as it was before. Next. So this is the before maintenance starts for no fault. You have to do the synchronization, data center 1, data center 2. Next one. Yeah, so this is the data center 1 where we have the master and slave, and the data center B could be in maintenance mode with other application. And after maintenance, it starts reverting when there is no fault. Next. So this impact of the site maintenance is negligible. Again, this is based on the state transition diagram and development of the equation and solving them. Next. Next. So these are the 4 types of data center we considered. In the first one, single non-redundant, the reliability is 99.671. In the second one, we have redundant component. That means the capacity has some additional capacity available. You can achieve reliability of 99.741. In the third one, you have redundant component and also redundant connectivity, IT equipment. So in the fourth one, it means all of the first, second, and third requirement. In addition, it has standby power supply. So in case the power supply fails, you can have additional power supply. The fault tolerant site infrastructure with electric power storage and distribution facilities. And this one can achieve up to 99.995, which is very close to the 5.9. So these are again state transition diagram model. You can get the more details from the paper which we have put. And this is the service impact error probability for various data center. Next. Next. So it is possible to provide 5 nines of reliability and availability with COTS hardware with the application level backup. Next. So the impact of the mean time to repair is not as significant if it is reasonably solved, for example, less than 10 minutes. Next. So the impact of the data center schedule maintenance is also negligible. So the cost procedure for software upgrade patching, they do not contribute significantly. So the thing is different grade of reliability for data center can be achieved, and 5 nines of availability can also be achieved using type 3 and the type 4 data centers, where you have additional connectivity capacity, and in the type 4 you have redundant capacity, redundant connectivity, and standby power supply. I think that's, yeah.
You
Thank you very much.
just on time. Thank you. So, well, still, if you feel like we have time for 1 or 2 very quick questions.
But we would appreciate if you ask question and...
But it's extremely difficult, so you talk to your Bobby, as he deserves. Well,
Thank you.
People don't want to torture you. So thank you so much. See you all in Prague.
Thank you.
Thank you, and I'll also
yeah,
discussions on the mailing list.
Yeah, for sure. And bring the whoever has the blue sheets. Exactly. Thank you.